Okay, so today we are going to have, we are going to discuss the lecture 4 of audio production techniques. Lecture 4, actually today it is, so officially it is 5th lecture, but we are going to discuss the lecture 4 slides. Because last week it was so mostly the practical of the previous lectures, right? So today in this, so we are going to talk about microphones. So the idea is that in recording, so the microphone would be like, so when we are recording, so the microphone would be the first element in the link, right? So later we do a lot of other stuff to the signals, and then with computers or other so mixing. So in our case, like we are mixing with software. So in sound production process, so the microphone is the first link in the chain. So usually it captures the sound, the physical sound waves, and converts it into electrical signals, right? So we have sound waves here, and then the mic is the device that converts this sound waves into, so this is sound waves into electrical energy, electrical signals, right? So that's why it is important, right? So I thought of discussing it first before going into the other stuff in this chain, right? So let's talk about mics today, microphones. So we are going to talk about microphones. So what is microphone? The basic mechanism and the structure of a microphone, and then types of microphones, and then some practical aspects of microphones, basically the placement of microphone. So that's the most important thing. So how to place a microphone. So for example, like, so now you hear my voice through the microphone. It's a very, very basic microphone that I'm using with my, so in my headset, right? So the placement of microphone is very, very important in a professional sound audio production. So you may have seen in, so maybe not like firsthand, but maybe in a television or in some videos, you may have seen that audio production studios, so that the recording studios, so they use different types of mics, so different qualities, different shapes, with placing them in different places, by placing them different. When it is vocals, when someone is singing, so the capturing that voice or that vocal sound would be different from capturing an instrument such as a piano, right? So in piano, so the mic is placed in a different manner, right? So we have to consider many different things. And the other thing is, like, when we are using mics, right? So there are no rules actually, right? So which way is good, which way is bad, it is up to the situation, up to the application, up to the sound engineer, right? So the creativity of the person who's, for example, the sound engineer, the creativity of the sound engineer would be the most important thing. So there are no rules. And so if someone asks, like, which would be the best mic, right? There's no such like, there's no correct answer for that, right? So that means like it's again like similar to the software, DAW software that you are using. So there's no correct answer for the question that which would be the best software, right? So it is any software which is good for you, which is comfortable with you, would be the best software. Similarly, the mics, like the based on the situation, based on the application, based on the sound that you are recording, it is different, right? Okay, so so let's talk from the basics, right? So the microphone, so we usually call the mic so MIC, right? So when you are calling like miking, so sometimes MIK, ing. So both are used. So microphone is usually the first device in the recording chain. As I told you, a mic is a transducer that changes one form of energy, which means sound waves, into another corresponding form of energy, electrical signals, right? So in so a few weeks ago, we learned that we are using like in computers. So we are using not just electrical signals, right? So electrical signals are usually those are basically we consider as analog, right? But here in computers we use digital signal. So however, at the point of the microphone, so it is an analog signal. Actually, it is in the microphone. It generates an analog signal, the changing of voltages, right? So the electrical signal is generated in microphone. So like later in the process of the recording, so it is converted into digital based on our requirement, right? But at this point, it is an electrical signal. Okay. So in audio production, 3 types of mics are used. 3 transducer mic types are used. So most common one is dynamic mics, and then ribbon mics, not very common, but like in modern techniques of ribbon mics, now they are again like, I mean, they are somewhat popular. And then condenser mic. So condenser mics are used so mostly in professional work. So if we consider the dynamic mics, they are very common and not very expensive, right? So affordable for general users. On the other hand, condenser mics would be a little bit expensive. Right, so let's talk about each of these types. Okay, so dynamic mics operates by using electromagnetic induction. So electromagnetic induction is a process of generating so here I have given that. So the simple theory of electromagnetic induction states that whenever an electrically conductive metal, right? So this is how we generate, in most of the cases, we generate the electric current. So electrically conductive metal cuts across a flux line of a magnetic field. So if you have a magnetic field, if any metal, electrically conductive metal, cuts this flux line of the magnetic field, a current is generated. Electric current is generated in that metal. Right. So if we have, so this is suppose this is the flux line of this electromagnetic flux line. So between these two sides. So if any conductive metal cuts, right? So these flux lines. So then electric current is generated here, right? So usually it is like very, very general physics, right? So this is electromagnetic induction, right? So this is used in dynamic microphone. So here, so we have diaphragm. So diaphragm, it is a very, very thin surface, right? Diaphragm face is here, right? And then, so this is sensitive to the acoustic pressure, right? So that based on the pressure, so this diaphragm is so it is sensitive to the pressure, right? Okay. So then, so there's a coil, right? So here, so we call it's moving coil, or so we call voice coil. So it is displaced in proportion to the amplitude and the frequency of this acoustic pressure. So acoustic pressure means so it is sound waves. So based on the sound waves, magnitude and the frequency, so this coil is displaced. So based on the sound waves features, frequency and amplitude. So with that displacement, electric current is generated, right? So analog audio output signal is generated. So that the current is generated based on the frequency and the amplitude of the sound wave. Because this is displacing, or the it is it's vibrating. So based on these acoustic features, right? So then in this moving coil, the signal is generated. So it is all analog sound signal. So this is, and then the magnetic, so there's a, so heavy magnet is used here, right? So this is magnetic housing, and then, so magnet is used, it is a kind of heavy magnet, and then so based on the movement of this audio signal is generated, right? So it is used electromagnetic induction in dynamic microphones, right? So so these are some features of dynamic microphones. So they have big magnets, So these microphones are relatively heavy. So then diaphragm must move relatively large distance, right? So it has to move large distance. So the slower transient response, right? Because it has to move long distance, it takes time. And then, so these are durable, right? Can handle a high SPS, right? Inexpensive and most commonly used. So most of the mics that you can see are dynamic mics. However, when it takes high frequencies, right? Sometimes it is incapable of capturing high frequencies. So usually like 5 to 10 kilohertz, 5 hertz to 10 kilohertz. Huh? Yeah, so it would be the range that it properly captures. Then phantom power, right? So phantom power is like for some mics in next slides. So we are going to learn some other types. So in some types of microphone, for example, like condenser mics, so they need phantom power, right? So that means some electric power is needed, right, to generate the sound. But in this case, we don't need such power. So it can just generate the sound, audio signal. So often used in close miking within foot of source can be, yeah. So it is used in like even in when we are using mics, so we have like distance miking and then close miking. So mic is closer to the source, and then mic is in distant miking. So mic is in some distance to the source. So dynamic microphones are used basically in close mic, right? That means one foot with the source. So that could be considered as close. So dynamic mics are used in close miking. I mean, so these are like generally they are used in close miking, but it can be used in distant miking as well, but sometimes not very effective. So generally used in concerts and live performance. Right? So in audio recording, also in studio recording, usually we expect more precise capturing of the sound waves, right? But in concerts, so live performances, so there are, I mean, precise capturing is not the number one, or it is not so necessary, because there are a lot of noises, and then if it is live performance, there could be some the crowd, they are making a lot of noises. So with all those things, and the precise capturing is sometimes not very meaningful. In such cases, we can use dynamic microphones. The second type is ribbon microphone. So ribbon microphones are, again, they are using electromagnetic induction as well. So however, their mechanism is a little bit different, right? So it uses a extremely thin aluminum ribbon as a diaphragm. So diaphragm is a very thin surface which is moving, right? Which can be moved based on the sound, right? So here we use a special diaphragm which is called a ribbon. Right? So it is aluminum. It is aluminum. It is extremely thin, like definitely less than half a millisecond, right? 0.3 0.3 millimeters, right? Very thin. So here, so we have the magnet. So in previous case, so we have a voice coil, right? So it is displaced, right? So based on that, the signal is generated. So in this case, so we have the diaphragm surrounded by the magnet. So the diaphragm is displaced. So based on that, so we capture, so this is aluminum, right? This is aluminum. So the so based on the displacement of this ribbon, electric current or audio signal is generated. So it is taken into this transformer, and then it will generate the audio signal. So sound pressure variations between the front and the back of the diaphragm cause it to move and cut across these flux lines here, right? Inducing a current into ribbon that proportional to the amplitude and the frequency of the acoustic waveform. So it is its output signal is too low, right? So this output signal is, if we compare with the previous dynamic microphones one, this is too low. So we have to use a transformer to boost the output signal. So this transformer, it boosts the output signal. Okay. So it is ribbon microphone. Right. So then condenser microphone, third one. So in condenser microphone, so there are two plates, right? So the front plate, it is a diaphragm, and then so these two plates, the first one is moving, the second one, the back plate is fixed. Right? Actually, in condenser, or sometimes we call capacitor, right? So if you have done so electricity in physics, so I hope you have done. I'm not sure how much it is covered. So however, this capacitor or condenser, right? So it is so that concept is used in condenser microphone. Condenser mic operates on electrostatic principle, right? So that means like in the principle used in capacitors or condenser. So here, audio signal is generated. So based on the movements of the front plate, right? So here, yeah. So I forgot to share. So at the this static principle, which is used in condensers. So here they are basically, so there's a formula that can be used in this case, the voltage, and then the signal, and yeah, the capacity or the yeah. So let me. So give me just 1 minute. I'll share that one exactly. Yeah, so this one. So this is, so Q is the charge, right? So Q is the charge here, generated charge. And then C is the capacitance in farads, and then the V is the voltage, right? So then these two surfaces. So then the charge, capacitance, and the voltage, based on that, the charge is generated in here, right? So that principle, so this principle is used in this case. So in this mechanism, so there should be a, so here there should be a, a general or voltage. So with this battery, there should be a current here, right? But based on the changes of this one, so we can take, we can generate, so it can generate changes of voltages, right? So the battery should be there, right? So in previous cases, in dynamic, so we don't need any so phantom power, right? In this case, we need so initial electric signal, electric current, the voltage which should be there. So that is provided with this battery, right? Sometimes in the mic, so we can place some batteries. Or in some cases, so I don't know whether I have mentioned that. Yeah, so phantom power is necessary, right? So sometimes that power is provided to the mic from our so mic is connected to a audio interface. So that interface sometimes provides that power, right? So we call phantom power, right? So that is necessary, right? So this is condenser mics operates on electrostatic principle. So here there are two plates. Those two plates form a capacitor. So these two plates work as a capacitor. Together work as a capacitor, right? So initial power is provided. So based on the changes or the movements of this diaphragm or the moving plate, audio signal is generated here, right? Condenser microphones. So condenser microphone, let's see their features. So So diaphragm made from very thin material. So the sensitivity is high. So that means condenser microphones can record sensitive sounds, right? For example, in our previous cases, so for example, dynamic mics are generally used in concert, live performance. Sensitivity is not not a big consideration in such cases. So, however, the condenser microphones can be used in studio recording. So if you use, for example, like vocal recording, so condenser microphone would be the best option. So if you have choices. So I'm not saying that, so if you have just the only option you have is a dynamic microphone, use that, no problem. But condenser microphone would provide more quality audio. Diaphragm must move relatively small distance, right? So these are very thin. So diaphragm doesn't have to move a long distance, right? So that means the fast transient response, right? So phantom power is necessary, and then delicate and accurate. The quality wise, it is good. So cannot handle high SPMs, right? In for example, if you are using condenser microphones for in a rock concert, sometimes it won't be the suitable match, right? So internal preamp may be transistor or tube based. Often offers less coloration, sounds more natural than dynamic microphone, right? More sensitive frequency response and can pick up subtle nuances of performance more effective, right? The standard for more audio application that requires maximum clarity, subtlety, and detail in the recording. So it is the same thing basically. So those are good for the clarity. If we need quality recording, so then condenser would be the best option. So relatively expensive. Right? These are expensive than the previous ones. Very fragile. Yeah, the other thing is very fragile. So you cannot just for example, like the dynamic mics would be, so you can throw them and then you can kick them. So I mean, they would be okay, but these are very fragile, right? So you have to properly take care of condenser mics. So basically, so if you use for audio, so for example, vocal record. So this is a good option. And then for some instruments, so these are good. This would be a good option. Right? So, so we are going to talk about those different types of so vocal recording and those things separately, right? So condenser microphone, right? So so when we talk about so these are the three types: dynamic, ribbon, and condenser. Then, so when we talk about microphones, right? So we have to consider something. So one particular thing is directional response. So the direction of the sound source, and then where you placed the mic, in which direction, right? It is important. It's very, very important. So the directional response is important. So in directional response, based on the directional response, so we have different types of mics, right? So we can identify three types of directional responses, right? The directional response of mic refers to its sensitivity, right? So how it is sensitive to the sound and how it is capturing those sounds at various angles of incidence with respect to the front of the microphone, right? So when we consider the mic, right? So this is the front of the mic and this is the back, the rear end of the mic. On axis means, so the source, the sound is in the direction of the mic directly, right? It's in the direction of the mic. Suppose the source is here and then the mic is here, right? It is on axis, directly come to the mic, right? So you have to consider this as in 3D space. Huh? So this is 3D space, not just 2D. Like, so it is shown in 2D space, but you have to consider it as 3D space, right? So suppose this is, so we are looking at the mic on top, right? So then the back of the mic, it is considered as 180 degrees, right? So on axis, that is 0, right? So then, so the mic is placing one direction, so sound is coming from back. Right? So the basic idea here is, so if we have a mic, right? So mic captures the sound from here, right? can capture the sound from here. So if sound source is here, then it cannot capture those sound waves directly, right? So then that's why we consider this, right? So then we consider this as 0 angle, and then we consider 90 degrees angle, and then 180 degrees angle, and then 270 degrees angle, right? Or source could be anywhere in between as well. So these are the main points, and then it could be anywhere in between these points, right? It could be here, 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 and here. The directional response of mic refers to its sensitivity output level at various angles of incidence with respect to the front of the mic. This is considered as front or on axis. So based on that, we give values or decrease to different places of it is 3D space. Some microphones have variable patterns with switches or interchangeable capsules. The types of directional responses are divided into 3 main categories: omnidirectional, bidirectional, and unidirectional. Right, so we are going to talk about those things one by one. A polar pattern is a graph to show directional properties of microphones. So polar patterns. Right? So I'll show you some several polar patterns for these different directional types, directional response types. Often are found in microphone user manual or promo material. Right? So if you buy a microphone, so this polar pattern would be explained there. Right? Right, so omnidirectional, right? So that means gather sound from all around, right? So whole and omni, right? It can capture sound from all directions. Similarly, right? Like so any mic can capture sound from different directions, but the levels would be different. But in omnidirectional, equally captures sound from all directions, all around. Useful for gather reflections and space of a sound. Right? Not considers a directional microphone. So these also omnidirectional microphones are like, so there are some types of microphones, we call them directional microphones. So they are sensitive to the direction. But the omnidirectional ones are not sensitive to the direction. It doesn't care where the sound is coming, so it can capture. So in omnidirectional, so no proximity effect. So proximity effect, so I'll explain it in later slides. So it is not available in omnidirectional microphones. Then unidirectional. So unidirectional means get a sound from one primary direction. As I told you, like microphones, they can capture sounds from different directions anyway, like not equally, but the thing is not equal, right? So here in unidirectional ones, so they have a primary direction. So they can capture sound from, they can capture sound well from one direction. That's a primary direction. Other sounds could also be captured, but partially, not as the primary direction. So useful for focusing on a singular sound source. If sound source is just single sound source, if someone is playing a music instrument, so for example, like a flute, someone is playing flute, so unidirectional one would be okay. If someone is singing, if you want to capture that sound, so then unidirectional one would be suitable for that. If you are recording vocal sound, that would be unidirectional one would be the most suitable, because we don't need any other sounds, right? We just recording someone's voice, right? So the unidirectional ones, polar patterns are like this. See? So the primary direction would be this one, and then so other, like, so basically this, the sounds from this area would be captured, right? Sounds from the opposite, like sounds from the 180 degrees won't be captured at all here. It is one direction. So, this type of unidirectional ones are called cardio. Sound is picked up mostly from the front. Mostly from the front. So there's another variation of that. So that means so mostly sounds are captured from the front. So however, from the other side, like the 180 degree side, some amount of sound, so sounds would be captured. So this is supercardio. Right? So however, so these are unidirectional. So unidirectional. So priority is given to just primary direction itself. Cardioid or supercardioid. And then bidirectional. So bidirectional, so in this case, in a supercardioid, from 180 degrees side, so we capture some amount, right? But in this case, it can equally captures two directions, sounds from two directions, from front and from back. Gather sound from two sides called a figure 8. So we call figure 8. So the this is like 8, figure 8. So that's why we call figure 8. Bidirectional. Useful for complete side rejection and so basically these are used in suppose if you want to capture two singers, right? Two harmonized singers, right? Then we can use bidirectional microphone, and then we can place two singers in 0 degree and 180 degree of that mic. Useful for capturing reverse reflections. Useful for getting two sources into one channel. Right. So if you want to record two sources into one channel, as I told you, like if you want to capture two harmonized voice into one channel as a one track, right? So this is very useful. So in ribbon microphones, so this is like very common in ribbon microphones, right? Right. So omnidirectional, unidirectional, bidirectional. Right? These are the types of directional responses that we can use with microphones. And then proximity effect. So the proximity effect is bass frequencies or the low frequencies, right? Bass frequencies are exaggerated when sound source is very close to directional microphones, cardioid or figure 8, right? So if we use a cardioid or figure 8, so these are directional. Omnidirectionals, we don't call them directional, but unidirectional or bidirectional, we call them directional. Right? So in such cases, so if the microphone is very close to the source, sound source. If the directional mics are very close to the sound source, bass frequencies are exaggerated. Right? So for example, like when I bring my microphone very close to my mouth, right? So then if when I'm making these sounds, the bass frequencies or low frequencies, so those are recorded or captured with high response. The power of bass frequencies are high. So that's the idea. So here in this case, so frequencies and responses, right? So frequencies and responses. So usually in high frequencies, it is the same, but in low frequencies, based on the distance, 5 centimeter, 10 centimeter, 30 centimeter, the power of the signal is higher. ලං වෙන්න ඒ කියන්නේ source එකට mic එක ලං වෙන්න මේ bass frequencies වලදී ඒකේ power එක වැඩි. හැබැයි මේ high frequencies වලදී ඒකේ power එකේ වෙනසක් නැහැ. ඒක මෙතනදී මේ 18 එහා වගේ යද්දී ඒ ඔක්කොම එක මට්ටමේ තියෙනවා. දැන් මම mic එක මෙහෙම ලං කරාට පස්සේ සමහරවිට ඔකට අර බේස් එක වැඩිපුර දැනෙනවා කියලා මේ අර කියන්නේ low frequencies වැඩිපුර සද්දෙන් දැනෙනවා. ඒක විශේෂයෙන්ම මේ directional microphones වල තියෙන දෙයක් මේක. figure 8 හරි cardioid. This is called proximity effect. So this is in bidirectional or unidirectional microphones. So low cut filters are often provided on microphones to mitigate this. So low cut filters means the power of the low frequencies would be cut out, right? Low cut filters. So we are going to talk about these filters later, right? So low cut filters would be one possible solution. So these low cut filters are provided on microphones itself to mitigate this, right? So that's this is called proximity effect. So in omnidirectional microphones, proximity effect is not available. Not we cannot see proximity effect. It's a case of unidirectional or bidirectional ones. Right. So then, so any questions? Any questions up to now? Right. Right. So then the microphone techniques. Right. So the microphone techniques, a large number of types and models can be used for variety of applications. And it's up to the engineer to choose the right one for the job. Okay. So we have different types of microphones, different qualities, and then different types, different qualities, and different prices, right? So based on them, so you have to decide which microphones to be bought. So if you are a sound engineer, if you are recording audio, so you have to, so if you have a lot of money, then no problem, you can buy the best microphones available without any hesitation. So however, so if you are a beginner, right, so if you are in budget, right, like most of us, right, and then the resources are not, like for example, like, so we cannot, so if it is just a university studio, right, so we cannot get money from the government or the university to buy all the things that we need. So we have to prioritize the things. So in such cases, we have to decide what are the mics, so what are the mics and other devices that we are going to use, right? For example, like mics or the monitors, like the speakers. So we have different types, different quality ones. So we have to choose, right? So there are two paths that one can take when choosing the types and models of microphones. So the selecting a limited range of mics that are well suited for wide range of applications, right? So basically the idea here is buy general mics, right? So common mics which can be used for different types of applications. The other approach is acquiring larger collection of mics that are commonly perceived as being individually suited for particularly instrument or situation. So we can have large collection of mics, right? And then we can choose for this instrument, we can put this mic. Okay, for this this person, his voice, we can put this mic, and so on. We can so individually select mics for the instrument or the situation. So usually, so as a beginner, like it is recommended to go with the first approach, right? So general mics can be bought, and then which are not very expensive, and then the limited range of mics, and then we can use them accordingly in a wide range of applications, right? But in professional studios, so usually they go with the second approach, like the high-end studios in Sri Lanka, definitely they go with this approach. But in some budget studios, I mean, in Sri Lanka, I haven't visited like studios much, but I don't know, maybe like, but I have some experience in Japan. Like they have both types, like very, very, I mean, Japanese, they are very precise when it comes to these things like recording. So, so most of the cases they go with this one, but there are some studios, relatively smaller studios, so they go with the first approach, right? Somehow, like so, this is for the professionals, but so as beginners, as amateurs, so as like students, so you don't have to worry about these things much. Like for the assignments that I'm giving you, you don't need any special microphones. You can just use the microphone you have available in your computer or in your headset. That microphone is okay with the things that we are doing. But if you have microphones that you also, so just check the quality and then the applications that they can be used. So if, for example, like if Akalanka, definitely he's recording music. So in such cases, so Akalanka, so you can add something on this, like it's what's your experience in using microphones and all?
Yes, I have in my studio I have Rode NT1A, which actually cardioid one.
Yeah.
Most of Sri Lankan studios and home studios now currently using lots of condenser mics actually.
Yeah. So so usually like so if you are recording like in studio recordings, condenser mics are preferred actually.
Yeah.
Yeah. So the quality would be better than dynamic mics, of course. So Akalanka, so are you I mean, in some cases, are you recording live audio? For example, like a group of musicians or a group of instruments are played, and then like a group of people are singing. So are you recording such situations?
Yes, sir. There
Okay,
are two ways of recording those things. When it comes to playing instruments, we are mically separated. So it's recording as a multi-track. When it is come to some voicing parts, we can get as the same mic when it's here like occasional ensemble music like that. So it's come to a particular unique sound. So in different angles, different directions,
Mm-hmm.
there are 5 or 6 people with different volumes.
Yeah. Yes. Yeah. Okay. Okay, Akalanga, thank you. So actually, so there's a concept. So as Akalanga told you, there's a concept called spatial sound, right? So it is actually, I mean, so I know some people like they are doing their PhDs on that, like how sound is heard when they are coming from different directions, and then how those effects can be generated automatically, artificially.
Yeah.
Yeah, so that's one area of research that like some people are working on. So I don't know. I mean, I know one person. I just remembered actually, like, if possible, I'll ask him to give an presentation, maybe not in this semester. I'm not sure whether he's available. I just just remember, like, when you mentioned that, so it is one area. I mean, if we take this one concept and we can do research on that, that's one area that there are many research are available. Like spatial sound, right? In space, how sound is acting with different dynamics, right? Okay. Yeah. So when you are using microphones, as like Akalanka explained, like based on the situation, so different microphones, different techniques are used. So let's talk some of them, like in distance miking and so on. So in maybe in most of the assignments that I'm giving you, I'm not expecting you to record very precise quality sounds, right? You can go with the resources available for you. It doesn't matter. So if you record with your inbuilt mic of your computer, so that's fine, totally fine. Right. Okay. Right. So then when we talk about microphone techniques, so choosing the appropriate mic, however, is only half the story, right? So we have a lot of mics, different types of mics, and you can choose them accordingly. And then, so after that, you have to do something bigger than that. So that means placement of microphone. It is also important. It could be more important than choosing mics, right? The placement of microphone will often play just as important a role, and it is one of the engineer's most valued tools, right? So these techniques, so there are several techniques are used. So it is something very, very important. So there are mainly there are 4 microphone placements techniques. So however, so these are kind of so in-book techniques. But if you are kind of creative, so you can use out-of-box techniques, right? So it's mainly like for the sake of discussing this concept. So I'm discussing these 4, right? But right, like you can. So if you are an engineer, so you can choose. You can select your own techniques with the creativity and the situation and the application. So distant mic, a close miking, accent miking, and ambient mic. Right. So the distant miking, usually the mic is placed with a distance. It can be positioned at a distance of 3 feet or considerably more from the intended signal source. Right? It is placed in a distance, right? Direct distance. So in this case, you can see the direct sound wave as well as the reflections. Right? Reflections, it could be just walls, it could be the ground, it could be the roof. So those reflections would also be captured, right, in distance mic. Can pick up large portion of musical instruments, preserving the overall tonal balance of that source. Right? Allows the room's acoustic environment to be picked up and naturally mixed in with the direct sound. So direct sound and other reflections of the sound is mixed and captured. Right? It is a mixture of all these sounds, direct and the reflections. And if multiple sound sources, those sounds would be captured here. Right? Distance mic. Suppose it is a group of singers, right? Like Christmas carol, right? Like in such cases, so they use maybe 1 or 2 mics with some distance, right? Distant miking. So at least 3 feet or more. It is the distance. There are reflect වෙනේවත් mix වෙලා දැන් වෙන කීපයක් sound sources තිබුත් ඒ වගේවත් mix වෙලා මේක මේ අර overall tonal එක තමයි මේ ඇහෙන්නේ. Then close miking, the opposite of that. So the when close microphone placement is used, the mic often positioned about 1 inch. That means very close to 3 feet, right? Up to 3 feet. So it is called close miking from the sound source. This is commonly used in so it creates these things. Creates tight, present sound quality. Effectively excludes the acoustic environment. So we directly captures this source, sound of this source. And then the reflections would be mostly excluded. From walls, from ground, from roofs, those would be excluded. So if you want to capture one instrument, so sometimes, so if you have seen a recording studio, like sometimes in televisions, you can see in some programs, they have studio environment. So sometimes like when you watch those programs next time, check. So they have some special mics very close to the instruments. For example, like drums. So on top of them, there are special mics for hi-hat, for snare drum, right? So then for some instruments, there would be some mics very close to that. And then for singers, like usually in singing, we use close miking, right? Singers, so they use mics very closer to their sound source, their mouth, right? It is close miking. Right, close miking. So these are the most common, right? And then apart from that, so we have another two concepts, right? Like accent mic, a microphone that has been placed within reasonably close range to an instrument or section within a large ensemble, but not too close as to have unnatural sound, right? So the accent mic, its role is, so usually like in, so if you use distant miking and then close mic, right? So in such cases, when you are taking them into the mixing, right? So their levels would be different, right? And you can have a close miking, distant miking, ඔය දෙකේම තියෙන ඔය tracks අපි අරගත්තට පස්සේ ඒවයි තියෙන levels වල වෙනස්කම් තියෙනවා. ඒකට solution එකක් විදිහට තමයි මේ accent miking කියන එක represent කරන්නේ. ඒක the microphone that has been placed within reasonably close range to an instrument, right? So it is like in between distance and close miking, something like that, right? And then ambient miking. So this is something different. So ambient miking is, ambient miking places a pickup at such distance that the reverberant of room sound is equally or more prominent than the direct signal. So in ambient miking, it is capturing the other sound more than the direct signal. Suppose, like for example, in a live concert, if you place mics somewhere in the crowd, right? So they are capturing the music too, and so apart from that, mostly they are capturing the noises of the crowd, right? In a live performance, so suppose if you are presenting in a live performance, so most of the sounds that you are hearing is a mix of the music as well as the crowd is cheering and they are clapping and they are shouting, right? It is a mix of these sounds. So ambient miking, so they capture those sounds mostly, right? So if you want to make a live concert, if you want to give that feelings, that live feeling, so you may have to capture those ambient sounds as well, right? So the ambient miking does that. So mostly capturing the other sound than the direct signal. The ambient pickup is often cardioid, stereo pair or cross pair that can be mixed into stereo or surround sound production to provide natural reverb or ambience. So ambient mic. So distance, close and distance would be the most common techniques that are used, right? Right. So then when different captures, for example, low vocals. So I have given just a few examples here, vocals and strings here, right? So then close captures. When it comes to close captures, so if you are capturing close sounds like in close miking, right? So in general, monophonic captures are close, right? In close capturing, like monophonic can be, I mean, it is like monophonic. So monophonic means just one track is recorded. So in stereo, in contrast, in stereo, so we are capturing two tracks. So for example, like as human, we are listening to stereo, right? So we have two ears. So we capture sounds from these two ears, right? So then from left ear, we capture sounds from our left side more. And then from right ear, so we capture sounds from right side, right? Strongly. So, other sounds would also be captured, but strongly, like, so for example, if you clap to your left ear, so you can hear it from your right ear as well, but not as strong as left, right? So that is like that spatial sound capturing, right? So it is stereo, right? So we are having two lines of inputs into us. So that's what it is, stereo. But so monophonic means we are capturing just one signal, right? So like for example, so suppose if you record on Audacity, right? Generally, so if you just record something, so this is mono, right? So here, so if so monophonic means just one track is recorded here. But if you change it to stereo, right? So if I record now, so this is mono. Right? So now there are two tracks, right? Track 1 and track. See? So two tracks are, that's stereo. So when you listen to some music, like you can identify those stereo, right? From left ear and right ear. So different sounds, so different parts could be projected into two lines, left and right. So that's stereo, right? But in a mono case, so if it is recorded and if it is sent to your headphones, so the same sound would be sent to both ears, right? So that's a monophonic and stereo, right? Sometimes we call monophonic and polyphonic. Different tracks, right? Like it could be stereo means two, right? So monophonic means just one sound, just one sound. Polyphonic means multiple sounds, multiple instruments are played. So multiple people are singing, right? So close capturing, so in most of the cases, it would be monophonic. So we are capturing just one source. Closeness offers an intimate sound and good isolation. Least leakage. All right, so leakage is another concept. So leakage means, so if suppose if you are singing, if there's one person, right? Person 1 is singing, right? So we are looking at the top, right? Looking from the top, right? And then another two playing an instrument, right? Playing an instrument. Suppose we have a mic here to capture that. So we have a mic here to capture that. The leakage means sometimes, right? This is to get the direct sound of this. This is to get the direct sound of this. Sometimes this sound can be captured from this one, and this sound can be captured from this one. This is called leakage. To avoid leakage, so we can do several things. One thing is, so we can have close capturing. We can move these mics closer to the instruments or the sources. That's a one thing. And another thing that we can do is, so we can maintain the same distance, but we can make these instruments apart, right? So we can move this part. Now, එහාට අරන් යන්න පුළුවන් the violin එක හරි මොකක් හරි instrument එක මේ පැත්තට. Right. So now it will be difficult to have leakages. More direct sound would be captured. This wouldn't be available. Right. So the leakage is that least leakage. So in close capturing, we can reduce the leakage, and then the good isolation can be achieved. Closeness may remove and reduce reflections, ambience, reverb, right? So ambience, the other sounds won't be captured much, and then the revibrations. So that means the reflections. Reverb means එකම සද්දය ආපහු හැමතැනම සාමාන්‍ය reverb කියන එක තියෙනවා, revibration. So reflections are mixed with the direct sound, so reverb. So those ambient and reverb would be reduced. Closeness can lead to unbalanced frequency response. So however, when it is closer, right, these things could happen, right? In low frequencies, sometimes the power would be higher, bass frequencies. That could happen. Closeness can lead to this undesirable airburst or physical contact. Right? So in this case, ribbon mic. So otherwise the figure 8 or dynamic cardio and large diaphragm condensers, most often used, right? In close capturing, so all these are used, but mostly so large diaphragm condensers. would be preferred. In close capturing, basically, so I'll explain it in low vocals, right? So anyway, close capturing, right? So the same idea here, close miking, the same idea, same idea. Right, so then when we take vocals, if you are recording vocals, so what are the things, what are the techniques to be considered? So if you take, like, if you play piano, so the other noises, there won't be much noises if you play piano. Even if you are not a professional pianist, if you play, the noises would be like, so whatever the note that you play, it would be played. But in vocals, a lot of air, mouth noises and breathing noises would be there, right? So when I'm talking now, so you can hear like my breathing noises, and then like if I they accidentally make some sound like this, right? And then breathing, and then sometimes if I drink a water, likewise, so those noises would be there, right? When we are singing, definitely such noises won't be there, but anyway, the breathing and other noises would be there. So proximity to nose can increase nasal sound, like sounds from your nose, right? So that would be increased. And then sounds like, if I make sound like some other noises, if I'm making, if I'm talking some other noises, like for example, like if I say some words, some unnecessary sounds would be added, noises would be added. Plosives, so we call them plosives, right? To avoid that, so we can use pop screens. Or sometimes we call pop filters, pop screens or pop filters, right? So you may have seen, like when some like when singing, right? So in front of the mic, so there's a screen, right? There's a screen and then the singer. Right. This is a mic, and this is called pop filter or pop screen. To filter those other noises. Only the important ones would be captured, others would be filtered. Not all, but most of them. So when vocals are recorded, 6 inches to 20 would be recommended. So this is not a rule. So it is up to the engineer and the producers, right? But this is recommended. Large diaphragm condensers always prefer. At high quality, large diaphragm condenser mics are preferred. So when another thing, like when sometimes it is just some people say it is good to have the mic like somewhat some amount of upper level, right? That means you're singing into like upper, right? So then sometimes it says that's better, right? But it is not a rule, right? Like this here, see? So the mic is a bit upper level than the singer, and then pop screen is there. Because when it is a little bit upper, so sound is projecting well, and then the other noises would be a bit reduced, right? Okay, so when it is the vocals, so for example, if contrast strings, so if you are recording strings, so the close captures of strings can be very unnatural, right? So if it is like the vocals, if it is very close, it would be kind of not very natural. You can do that, but not recommend. Often need some space for resonance and smoothing, right? So to mix those different frequencies, right? It needs some space, right? So in such cases, so the distance to have would be if it is more than vocals, that would be better, right? So again, it is preferred large diaphragm condensers, condenser mics. And the diaphragm should be aligned to the plane of soundboard. So soundboard, so if it can be aligned to the soundboard, so you can capture better sounds from string instruments, right? So likewise, in different instruments, so we can identify different techniques. So I'm not going to talk all here. So I'm just giving just 2 examples, but these are not rules. Again, I'm saying it again and again. These are not rules. Okay. And then stereo versus mono microphone techniques. Like stereo mic techniques, right? So mono techniques, so that's obvious. That's obvious. So you are recording with one microphone. That's mono, right? That's obvious. But in stereo, right? So how to record stereo? Yeah. So that's let's talk about that now. So instruments that are large or have diverse points of resonance or movements are often captured in stereo, right? So suppose if you are playing a large instrument, so piano, right? Right. So piano. So we have a lot of keys in piano, right? So sometimes at the same time you are playing one key here and another key here, right? It is possible. So in such cases, if you are capturing this with just one microphone, won't be not enough, right? In such cases, so the stereo capturing would be necessary in this case. So piano, harp, percussion, like keyboards, and sometimes like drums, so acoustic guitar, right? Sometimes stereo capturing would be necessary, right? Instruments and sound sources that have focused output are often captured in mono, right? In some cases, like single drum or just one part, right? So then mono capturing is okay, but in some cases, stereo capturing would be necessary, right? So in stereo capturing, so there are several ways, right? These are few, but some other mechanisms are there. We are using two mics placed in different places. So these techniques are like two mics are placing in different places, different locations. So based on those locations, we can identify different techniques like space pairs, XY, or TF. For the purpose of this discussion, the term stereo miking techniques refers to the use of two microphones in order to obtain a coherent stereo image. So stereo image means a stereo capturing of that sound, right? These techniques can be used in either closed or distance miking or single instrument, vocal, large, like in different situations, these stereo miking can be used. It could be closed or it could be distance. So we can use stereo miking, right? So let's talk about, briefly talk about these things. Space pair stereo miking. So in that case, right? So this is, ignore that. So these are taken from one of the books that I'm referring. So spaced microphones. So we place this mic with some space, right? In a left and right. So then we capturing the same source from two different angles. So something like that, from two different places. This technique places two mics of the same type, manufacturer and model, right? So that's something to be considered. It's better to use two similar mics. So it could be just one, like few feet, or it could be like more than 30 feet, and use time and amplitude cues in order to create two stereo. This is spaced pair stereo mic. So generally, you are capturing the same source with two mics. Basically, that's the most primitive way of stereo mic. And the other thing is, so you can use two mics like this, two cardioids placed at a 90-degree angle to each other. These are in 90-degree angle. So usually, I mean, it is not, it doesn't have to be exactly 90. It would be 90 to sometimes 135, right? In between these, right? So even in this case, it is, you can see it is more than 90, yeah? Right? This is called XY stereo mic. Microphone on the left is wired to the right channel and the vice versa, right? Because this one is taking, the mic on the right is taking left, sound from the left, right? So like this, right? So the mic on the right is taking the sound from left directly. Mic on the left is taking sound from the right directly. So that's why this is going to right and this is going to left. Lose a little depth, but lack of ambient information. Right. So this is taking the sound, like in this case, this is close, right? So this is close mic. Basically, this is good for close mic. And then ORT, right? In this case, for two first order cardioid microphones with, so this is a bit, we don't need width here or here. So somehow, anyway, with a spacing of 70 centimeters between microphone diaphragms. right? So diaphragm is here and here. So they are 17 centimeters away. And the angle is about 110 degrees. Actually, this is, it's usually reproduce stereo cues similar to how human ear perceives directional information. Actually, our ears are placed some in a similar manner, right? So between our ears, like it has generally this angle, and then those are apart from 17 centimeters. සාමාන්‍ය මිනිස්සෙක් අහනවා වගේ කැප්චර් කරගන්න ඕන නම් ස්ටීරියෝ ඒකට තමයි මෙන්න මේ මෙකැනිසම් එක පාවිච්චි කරන්නේ. Works well in poor acoustic environments, well suited for concert tape. Right. So these are three. There are more. There are more than these. There are several other ways that you can creatively place microphones. Right. That's stereo. And so these are basically, like, generally how mics can be used in recording. Right. So with that, so I'm going to conclude today's lecture. And then I have the first assignment. So I will upload it to the LMS today. So after this lecture, right? So any questions from the lessons? So in this assignment, actually what you have to do is just you have to produce, like create the audio project of any software that you be available with you. Like it could be a DAW or like software like Audacity. So Audacity is sometimes considered as a DAW, but like generally with the capabilities with that, like sometimes some people don't consider it as a DAW, but it doesn't matter. So you can use Audacity or any other DAW for this. So you have to use multiple tracks, at least 3, right? At least 3. So one, you have to record, right? It could be like you are talking, or some sounds, like environmental sounds, or it could be singing of your dog, so whatever, right? So you can record something, and then you can import, right? So in so for example, in Audacity, if you take, so you can import audio or sometimes MIDI, right? So you can import some audio file, like right. So for example, like any audio file can be, see, imported, right? Yeah, so then so it could be a song, right? So it could be any it could be song, it could be any sounds, recorded sounds, it could be someone is talking, right? Any sounds imported, right? Imported sounds, and then you can use multiple ones, right? So you can mix multiple imported sounds, right? And then the other one is, right, like so if you are using DAW, like virtual instruments, or generate sound from some plugins, right? It could be musical or just irregular, non-musical sounds. So generate some sounds from virtual instruments, right? At least one, huh? Like, so you can have more than one, and then you can creatively mix them, and you can add some effects, right? You can add some creativity and do some experiments, right? Right, like if possible, try to make something with purpose, right? For example, like to generate some horror sounds, like it's up to you, right? Like so basically what I want is the experimentation. So you do experiments and you play with the tools, and then so finally you have to generate a compressed audio. So that is what you have to upload to the I'll give you the upload link, right? I will give you the upload link, right? So based on the situation of the LMS, right? So then the second part is actually, so you have to write a report of your project, what you have done, right? The brief introduction to the DAO or the software that you are using, and then the introduction to the project, what you are doing, what's the purpose of, right? So then the sounds that you are using, what did you record, and then you can add how you recorded that, right? So the miking techniques that you have used, right? Those things, and then the main steps that you follow, right? What are the things that you did? If you can capture some screenshots like the original one, and then you change it to this, right? Likewise for the main steps, not I mean, if you do many things, right? So then you don't have to add everything, but the main steps that you did, and the purpose, the reason that you did that, and then what you observe after doing those things. So likewise, you have to provide a report. It doesn't have to be like less than 5 pages, right? So, but if it exceeds 5 pages with the screen captures, so then that's fine. But just the explanations, maximum 5 pages, right? Like screen captures them with him, some pages gone to prashnayak na. Habai then explanation so ලියන දේවල් maximum 5 pages maximum. Right, you don't have to go beyond 5 pages. Right, so the tentative deadline is 30th December. Right. So you have to create a zip file and put the report and the your compressed audio file into that and upload to the link. Right, so that's the assignment one. Right, so today that's all. So I'm going to conclude the lecture now. So next week, so we are going to talk about the other components of the audio production chain, the recording chain. Right. Okay, so so if you don't have any questions, so we can conclude. So thank you for joining, and I'll see you on next Monday. So if you have any questions, anytime you can contact me and you can ask. Okay. So today the participation is a bit low. I mean, it's just half of the students. So Krishan and so I think who is the other representative? Manovi?
Yes, sir.
Yeah, Krishan and
Yes, sir.
Manovi, right?
Yes, sir.
Yeah, so just inform other students who are not here. So I'll be observing the attendance. So that means I'm not going to give the marks for the attendance, but who's not participating. So I'll note them, right, to check not anything, but how they are doing, right, whether they are following the things properly, right. So I will be observed, right. So if anyone is having a good reason not to be here, yeah, so those are fine. So they those reasons can be informed. So I will give anyone such releases, but others if you are not just if you are just skipping lectures, so that's not good, right? So there is consider this as just the first warning, right? So inform others, right? So so I'm going to be, so the attendance would be closely observed. Okay.